In generative AI, the open source world is rapidly evolving, bringing powerful new technologies within reach of everyone. In this Hashi talk, we'll explore an exciting concept, RAG in a box, and see how we can build Terraform Companion PoC proof of concept using open source models. Hi everyone, my name is David Min, Senior Partner Success Solutions Architect at AWS. Let's start with a quick demo to get familiar with open source large language model and take a look at Terraform Companion PoC app with RAG turned on. Switching screen to demo here with Streamlit, let's take a look at what the language models can do as far as some of the pre-trained knowledge. We're gonna use prompting here. Let's take a look at a few questions. What is HashiTalk? Okay, so looks like the pre-trained model already has knowledge about HashiTalk. Let's take a look at a few additional questions. What is HashiConf? Okay, so the result shows us that even the small open source models like 7B models has knowledge about HashiConf. What about Terraform? All right, in this case, Terraform, here's a quick description, how we can learn what Terraform is and quick description of what it is. Let's see if language model can teach us how to get started with Terraform. All right, so showing us the step-by-step approach, Terraform plan, apply, and destroy. That's interesting. Now, going back here, it looks like the link that the language model provided, it redirects us to the download page. So looks like we just learned through the LLM how to get started with Terraform, and that looks good. Now, if I want to ask additional question about more complicated task, can the LLM perform? So let's ask a question about write a social media post on how to get started. Let's get a little creative here and let's see what LLM can help us. Okay, so it summarizes the steps in a very simple, easy to understand format. And then I can take this to social media to increase the awareness of Terraform. Now, let's take one step further. Perhaps we can ask language model to write a blog on this topic, how to get started with Terraform. All right, so we are looking at language model generating large context based on the context that it used earlier and be able to create a blog, which gives us a baseline for us to work with, and then we can sort of find the use case to post the blog to increase the awareness. And then the next question was about Terraform code for VPC, and looks like pre-trained models already have knowledge about Terraform, some of the AWS constructs, and VPC at this point. And that's very interesting. Now, let's compare that with our custom-made Terraform Companion, and it is using the top 7 most downloaded AWS modules for Terraform. The intention was to create the based on the standard template that was published and be able to generate the same consistent output for users. Now, in this case, Terraform code for VPC generated consistent output. Let's take a look at Terraform code for DB, in this case, RDS instance. And it's going through the entire section of the code block that we generated from the data set. Now move on to Terraform code for EKS. That's more complicated due to the fact that there's a lot more code in it. And also it's going through the generation one more time. And it's grounded on the data set we fed to the language model and the vector database. All right. All right, so let's tackle on more creative task here. Create a social media post just like what we did before on Terraform code for VPC. Again, being sort of using lots of emojis and try to create that intimacy with users. And then it looks good to me. We still maintain the consistency of the module config. And that looks good to me with some hashtag as well. Write a blog on Terraform code for VPC. Okay, again, tackling on more creative task, letting LLM to generate blog post grounded on the data set we provided. And it is capturing all the information and the steps for us to follow through. And that's it here. I think that gave us good idea of how we can take it. And then let's take a look at some additional details on the slide deck. Let's take a look at the progress in information retrieval. First, search engines we are all familiar with, and we do this every day. Now, if you move on to text generation, prompt goes in to a large language model and the response comes out. Large language models can now generate human-like text for a vast range of topics and styles. There are multiple prompt engineering options available as well, all the way from zero-shot, few-shot prompting, as well as in-context learning to augment LLM's text generation. However, a limitation is that current AI models don't have a grounded understanding of facts. They generate based on detected patterns, basically next word prediction, and sometimes getting too creative. And if you move on to Retrieval Augmented Generation, here language models are combined with context of knowledge and facts, and we can improve on the text generation. In this sample prompt for Retrieval Augmented Generation, we are feeding not only user's question in the prompt, but also the context that we receive from your source of information. You can ingest your own custom data to a vector database with embeddings model, so we can use semantic search based on the meaning of your question, and we can retrieve the relevant chunks from the database and add them to the prompt. Context is all you need for LLM to generate better response. By incorporating external knowledge, the LLM can produce more in-depth, factually consistent, and nuanced text. In our previous companion use case, as you saw in the demo, we have captured usage patterns of the top 7 most downloaded Terraform AWS modules from GitHub repo. That helped our Terraform Companion app to produce consistent Terraform code patterns grounded on our dataset. LangChain is an open source framework for building context-aware reasoning applications. In RAG-in-a-Box, we are using LangChain as a composable layer. It provides abstraction and orchestration from protocol all the way to observability. LangChain provides a wide range of integration. Templates provide composable app development using standard templates. LangServe helps developers deploy LangChain runnables and chains as a REST API. LangSmith provides observability. With LangChain Stack, you can streamline your prototype and app development. RAG in a box refers to a packaged solution that enables Retrieval Augmented Generation. It runs locally in your VPC, only using open source components, providing full privacy and control without relying on external APIs. As it runs fully locally, the user maintains complete data privacy and system control. It allows for rapid experimentation and prototyping, making state-of-the-art RAG technique more accessible for everyone to explore. Let's take a look at a few LLM options. On top, we have Code Llama 7b model from Meta. We have Zephyr 7b from Hugging Face, and popular Mistral 7b as well. The recent trend has been that the smaller 7b models outperform larger models in specific tasks. With optimization techniques like quantization, we can run 7b models in Amazon EC2 G5 2x large instance. In addition to that, we are running Quadrant vector database on a container locally. We are using open source BG embeddings model using sentence transformers from Hugging Face. LangChain provides document loader, retriever components, as well as the remaining orchestration. The entire tech stack runs on a single Amazon EC2 G5 2x large instance. One of the large language models that we can use is Zephyr 7b from Hugging Face, which is fine-tuned from Mistral 7b model from Mistral AI. And despite the compact size, and then compared to larger models, you can see some of the task-based benchmarks, it performs pretty well, especially on the extraction where we can use that specific task for retrieval augmented generation as well. For more details, you can take a look at the model card in the Hugging Face and find out more details from there. In this hands-on demo, I'll show you how to bootstrap Amazon EC2 instance and start testing your choice of LLM as well as RAG components. We'll use Streamlit for a quick end-user interface. We'll also use LangServe to provide REST APIs. Now let's take a look at EC2 instance. Now we have access to Jupyter Lab and how you can bootstrap this here. You can take a look at my blog post that I'm going to share later on. And the prerequisite here is that we've gone through all the dependencies install, and now we want to kickstart the Docker containers. So from the directory, we're going to go ahead and open up a terminal. And based on the quantized model for Zephyr 7b, we will use text generation inference from Hugging Face, and we'll load up the model in container. So it downloaded the weights and going through the sharding process. And then once you see the warm-up model, and then went through that and then default to 0000, now it is connected. Now let's move on to the second terminal, and this time we're gonna launch the Quadrant in Docker container. Again, same process. We're gonna run Docker to instantiate Quadrant. And these two Docker containers are running locally without relying on external APIs. So your data is 100% local within your VPC. Now, to make sure we can validate, go ahead and open up another terminal. We can run Docker PS, and we can confirm that we've got two containers running in our EC2 instance. Now let's open up one of the sample notebook here. I'm gonna go ahead and set up the Langsmith. Make sure Docker is running. We just did that. Using the Hugging Face TGI, we can configure the LLM model, do a simple prompting, and we can see the response from the LLM. We can also run streaming as well, and you can see with the simple prompt template, we can get the response streaming to the notebook. We can also test the next question as well, just to make sure the LLM model is responding. Now let's launch the Streamlit app that we prepared. And then we're gonna access the UI. Okay, that's perfect. Now that we have our LLM container and then Quadrant running, and we've tested the language model with simple prompting, let's go ahead and launch the LangServe to be able to serve our REST APIs. So again, coming back to Jupyter Labs, open up a terminal. We're going to go to My App directory and then launch the langchain serve command. And that's going to launch our LangServe, again, locally running on port 8000. And that's fully running. So that chain.py file ingests the data set that we prepared, and you can see that from Quadrant dashboard. So you can see the data imported along with the metadata pointing to the source, and you can see the vector database, the embeddings, length of 1024, along with the page content. And a whole bunch of Terraform code in smaller chunks ingested into Quadrant vector database. Now, earlier we launched the Streamlit app, and so you can access the UI from a LLM, as well as the Terraform Companion PoC UI is available for us to test. And from a REST API, we also get access to Fast API. You can also invoke multiple API calls here for testing and development as well. And take a look at the invoke method. You can see the details of REST API, and you have also access to streaming method as well. All right, so more details on the schema. And we're taking a look at streaming method as well. All right, so we're gonna open up another browser. Yeah, so we can access to LangServe Playground. Let's put a simple prompt, Terraform code for VPC. We're gonna see the identical output based on Retrieval Augmented Generation. We can see the VPC module displayed along with additional description. You get access to the intermediate steps where you can see what chunk of text that we retrieved along with the intermediate steps. So you can trace the details of how the Retrieval Augmented Generation is responding based on your input. You can also share the prompt or test that you just performed. Let's try another test. So Terraform code for EKS. Again, in a playground, give us access to simple test, as well as the, again, intermediate steps that will give us better insights on either troubleshoot or having more visibility. Again, going through the text generation, rather lengthy response, but nonetheless gives you the full context. And then, going back, we can also try one more test, Terraform code for S3 bucket. Okay, so let's validate our data set. So the data set that I prepared, just to give you a proof of concept, so we can steer the model to produce consistent output. So I'm using the top 7 most downloaded modules, and I use the usage section from each module, in this case VPC. We want to ground the LLM model to produce consistent modules, and that's captured in this markdown file. So you can see 7 files representing each services. RDS, for example, has sample usage as well. So we are feeding this to vector database, in this case Quadrant. We took a look at each page content as well. The embeddings model we are using has a dimension of 1024, so it can handle quite a complexity, sort of higher dimensional insights from a semantic search. So when you run the length serve, it includes the ingestion mechanism as well. So ingested these files. So when we go ahead and generate, either from Playground or in our Streamlit UI, we can see the effect of Retrieval Augmented Generation. So hope that helps. I can also share more details about the Streamlit app, and then all the rest of it should be available in the blog post. Another benefit of using LangServe is to be able to access remote runnable from your client. So by having 2 lines of code, you can access your LangChain chain service from your client. So it keeps really clean code base for your client, and you can go ahead and consume and invoke runnable.stream to be able to consume the streaming service from your LangChain runnable. My Medium blog posts provide more details on Terraform Companion proof of concept and RAG in a box running on Amazon EC2 using open source. You can scan the QR codes and get access to 2-part series blog posts. 3 tips for steering LLMs using prompt engineering. Number 1, clearly specify the task. Be very explicit about the kind of text you want the model to generate. Provide clear instructions stating the precise task, style, and length requirements. The more specific your prompting, the better the results. Number 2, use examples. Illustrate what you are looking for by providing 1 or 2 examples of the desired output. This gives the model a template to follow and improves its understanding of the task. Examples enable intuitive prompting. Number 3, iterate on prompts. Treat prompt engineering as an iterative process. If the initial outputs are not what you wanted, tweak the prompts systematically. After the wording, add or remove constraints, provide additional examples. Continuously refine the information fed to the model until the outputs match your intent. When bringing large language models into real-world applications, there are some important things that we need to think about. One key challenge is to make sure the model gives helpful, accurate responses, and we want to avoid situations where it might make up information or retrieve things that aren't really relevant. By adopting evaluation-driven deployment and working together on solutions for issues like these, we can find ways to responsibly apply these powerful technologies. Let's talk about the next steps and where we go from here. We want to take a look at experimenting with various data sources. Your data is your crown jewel, and we want to bring the models to the data and not the other way around. So let's make sure we can experiment with various types of data and make sure that LLM responds and delivers a quality response. We also take a look at evaluate the re-rank models to improve the retrieval mechanism. We'll also take a look at LLM and embeddings model fine-tuning to improve on the quality. We can also take a look at increasingly popular multimodal language models that has vision and other capabilities that expands the overall horizon for generative AI. Combining human expertise with the capabilities of generative AI will unlock new innovation that solves real problems. I welcome your thoughts and perspectives. Let's share how we can integrate specialized knowledge with generative models to drive real progress and innovation. All right, that's all I have. I hope that this talk was useful and inspiring. Let's experiment together. Thank you.